This is a walkthrough of the sorobandev.com remote tool and how to use it. But first, to get started, let's look at the Soroban contract that we'll be working with to demo all the features. It's called the toggle contract. It's got a couple of functions and they're pretty simple. It's just toggling a Boolean value from true to false. A couple of the functions don't have any arguments, and the third one, the toggle function, does have a single argument. All right, so let's compile this thing and let's see how to do it. Nice and quick copy from this guide here, and let's build. All right, finish building. I want to see at the size here, so let's see, target, release, WASM, all right, and then the release there, and what do we have? We have the project WASM file. All right, so this is gonna just show us how many bytes this thing takes up, and it's gonna be useful reference number later on, so 696. All right, so now that we've built a contract, we want to deploy it. Now we could use the CLI to deploy it, and there's a guide on how to do that. But I've built the remote tool specifically to make it easier for developers and not have to work with command line as much, because that can be daunting when you're just getting started. All right, so deploying a contract is a transaction. So you go into this send transaction section here. Now to deploy a contract, you do need to have a FutureNet account. I won't be covering it here, but you can see in the guides there's things you can do to get an account. But let's just assume that you do have an account, so you need a secret key. I'm going to take a secret key and copy into this field here. I'm going to select install contract code and select the project WASM file. So this is the 696 bytes that we compiled, and just double check that the size is the same. And what we're going to do is keep the footprint to automatic. Now, normally when you interact with Soroban network by sending transactions, you do need to provide a footprint. But in this case, this remote tool provides a capability where it can be automatically calculated for you, which is a nice helper because you don't need to interact with two sections here, specifically the simulate transaction. All right, getting back to the installation part. So when we compile a contract, we install it, we can then create. So first up, installing it. We're going to call this transaction. We're going to get a identifier for that transaction, and we want to see if it succeeded. So there's a section get transaction status that handles interactions with the get transaction status method for the Soroban RPC. We copy in the transaction ID and we call it. We can see the status is success. That means the contract code was installed, and on top of that, we get this handy binary value, which is actually the contract code hash, which is going to be necessary when we're going to create an instance of that contract. So let's go back to the send transaction section, and we're going to select the create contract portion. There is a field contract code hash, and this is exactly the value that we got from this transaction in the results portion. Okay, footprint is automatic, and we're going to call it again. So we get a new transaction identifier. We go into the status, and let's check the success. All right, so we have another successful transaction. And again, there's a results field with another binary looking value. This is base64 encoded, by the way. So this is the contract ID that we'll be needing everywhere when interacting with the contract. Okay, so now that we've installed it, we've created it, created an instance of the contract, we can go ahead and invoke it. So this is where the contract ID comes in handy from this value right here. And so it needs a function name. So we have 3 functions: on, off, and toggle. Well, let's go ahead and call the on function. It doesn't take in any arguments, and the footprint is automatic. We're going to call that. We get another identifier, and let's take a look at the, all right, success. So the result is the value we're setting it to. In this case, we called the on function, which, sets it to true. So that's what we were expecting. Now let's call the off function. We don't need to do anything else, just click call, and let's see how it went. Cool, so we have another successful transaction with a false value this time, and it makes sense because the off function sets it to false. Now let's try and call toggle. We know that it takes a single Boolean value as an argument. So let's change the name to toggle, and let's add an argument. Select the type. So Booleans are static values. We can select by selecting the static type, and then we set it to false. Let's set it back to true. Okay, so we've added an argument that's a Boolean true, and we can call this again. Okay, let's check out the transaction ID. Boom. So that was successful. We've set the value to true. Now to make sure this all works, we're going to set it to false. We're going to call it again and see if we get a false in here, because the return value depends on the argument that we provided. It's not a hard-coded true or false. So again, we set it to false. Previously it was true. We have a new transaction identifier. Let's go check out the value. And it's false. Cool. So this is how we interact with Soroban contracts. If it takes the arguments, we provide them. If it doesn't, the footprint is calculated automatically. However, if you want to venture into generating a footprint yourself, you can do that. Just go into the simulate transaction section. Now, you'll be providing exactly the same values. So I'm just going to copy paste everything here. So we're going to invoke a function with the contract ID. That's the same. Function name, I think I don't need to copy that. And we're going to provide a true as the argument. So what this does is it doesn't send the transaction, but it calculates the footprint. Now the response for humans is not exactly what we need. We can see how it parses it out. So ledger footprint, there's a read-only section, there's a read-write section. So maybe this could be useful for providing intuition on what the footprint looks like. But if we want to get the actual footprint value in the response, there's a footprint field, and we can just copy the whole thing. Then we can select manual and feed in the footprint. All right. So yeah, let's call this and see that it still works with the manual footprint. All right, so that worked. Cool. So we've checked out simulate transaction. You won't be needing this too much because send transaction has an automatic footprint option. We've played around with get transaction status. This is how you see if what you wanted to do went through. getHealth is just a sanity check to see if the RPC that you have set still works and functions. getAccount will enable you to look at account data, but currently it doesn't provide that much. We can check the return value here. So just present the same identifier or the address and the sequence number. All right, get latest ledger is a work in progress, so you don't have a valid return value here. Now, getLedgerEntry is very useful when you just want to query the state of the ledger. And specifically, since we're storing something using environment storage, well, it's useful to look up that value without calling the contract. So this is how you do it. You select contract data from here, and then you provide a contract ID, which we have over here, and the key type. So we're storing everything under the toggle symbol. So just select symbol, and let's see here, it's a toggle. So this will return the toggle value. So currently this is false, and we set it to false using this transaction. For fun, let's call this with true and see if the ledger entry updates. So right now it's false, we're calling it, and it's true. All right, get network is a work in progress, so nothing meaningful at the moment. Request airdrop is another work in progress. It does take in an address, so let's call this, again, method not found, but eventually this will fund accounts on FutureNet or TestNet. Now the last part is getEvents. So as you can see in the contract code, we had a lot of events being published. Essentially with every call, we publish an event. And we can actually query all the events that are coming through within a given range. At this point, it's roughly 4,000-ish or 6 hours worth of ledgers. So this gets populated automatically. As you can see, that changed, and the range is 4,000. So we can just click on call and see that we've been submitting a bunch of events to the ledger. We can see that, you know, we're calling on, we're calling off, calling toggle with true, toggle with false, and let's check is it all from a single contract? No, we can see that there's some events being generated from a different contract. Well, if we want to filter based on contract IDs, we can add the contract ID that we're interested in. So let's see here. Just a quick hack. We had 12 events without any filters. Let's apply this. And how many do we have now? We have 6. So these are only for the contract identifier that we provided. We can add multiple contract IDs, just separating them with a comma. But for now, I'm just interested in this contract. Now a section for looking for topics, it's quite interesting. So we can filter these based on the topic section right here. So let's say we're only interested in how many events have this symbol. So we can add a symbol for on. Again, let's check the numbers. So we have 6, and if we filter based on contract IDs and topics for the on function, we have just 1. Okay. If we do off, again, we have just 1. Now if we call toggle, this is going to be interesting. We're going to have an empty response. Now the reason for that is we're not sending just one topic. We're sending 2, the symbol for toggle and the Boolean value. So for that, we need to add a wildcard, which will, the length has to be the same as the length provided in the events tuple, which is right here. So 2 here, and we need 2 topics right here. When we call this, we get all the toggle events. All right. Lastly, we can use pagination here. So this is the token that we're going to use for paginating. So if we provide this and call it, well, then we're going to, this is going to print out all the events that come after the cursor. And we can have a custom limit. So let's see, how many do we have? We have 3. So let's say we want to limit to 2. Okay, so how many do we have now? We have 2. All right, so this is sort of the ability to paginate, the ability to filter. It's also a types filter, but you know, not that many system events coming through, and you most always going to have the contract type. This is not going to change the output if we select that, so we might as well unselect it. If you want to clear out all the filters, just deselect, call, and then those filters are gone. Just the pagination is left. Let's remove the limit. We have 3 because, you know, after the cursor. Let's remove the cursor, and we have 12 events like we did before. All right, so that covers the remote tool sections. If you want to find out about the RPC design, there's a document you can check out. It's linked in the remote section. It's got details on structure for every endpoint and the inputs and outputs. If you want to set a different RPC URL, you can go ahead and change that. And don't forget to set the appropriate network passphrase. If you're using a standalone network, you got to change that, otherwise it won't work. There's a setting for including the RPC method arguments in the URL. So for example, you can see here, once after we submitted this this call, our URL includes that call. So this is good for sharing, but it can be overwhelming. You can just disable this, store the updated settings, and that will not be included in the URL anymore. Just quick links for the methods, and there's some sample data. Obviously, if you don't want to type everything out, if you want to just try out some of these methods, you can click on the sample data section. This will fill out all the fields, and you can call these and see the results right away. Okay, so that finishes the walkthrough and demo of the SorobanDev.com remote tool for the Soroban RPC. I hope you find this useful. If you do, if you use it and have any feedback or something breaks, feel free to share your feedback with me on YouTube or Twitter or on Discord. All right, thank you so much. Bye.